Today in this video, we will talk about Spearman's coefficient of rank correlation. In our last video, we talked about Carl Pearson's coefficient of correlation. So what is the difference between the two measures of coefficient of correlation? So basically in our last video, we saw that when we are computing Carl Pearson's coefficient of correlation, we are working on a data that can be measured in terms of numericals. Like we have proper numeric values or the data is quantifiable. So in those cases, we can use Carl Pearson's coefficient of correlation. But sometimes we have a data that cannot be converted into numerical measures. Only we can do is we can just create a comparison. That is let's take an example of some characteristic. Let's suppose beauty. If we are considering a characteristic's beauty, we can obviously cannot give a measure to it. We can only say that person A is more beautiful than person B. We can only tell who is most beautiful or who is more beautiful, right? Similarly, if we talk about intelligence, which is another characteristics. So again, for intelligence, we can only create a measure or a comparison that, okay, person X is more intelligent than person Y. We can only create a comparison. We cannot give any numerical measure to it. We cannot quantify this data, right? So we can only say which is best, which is worst, which is most favored or more favored, or which is least favored, and so on. So what happens in these types of situations? What we do is we give them ranks. We simply give them ranks. So when we give them ranks, we are simply giving them a numerical measure which can only be used for comparison, right? So let's suppose another example if we take is for honesty. If I'm saying we can only compare that, okay, let's suppose person P is more honest than any other person X. So over here we are not measuring it numerically, but we are just comparing the two persons on the basis of their characteristic, right? So over here, now sometimes what happens is, let's suppose we are giving ranks. Let's suppose there are 10 people, A, B, C, D, E, F, G, H, I, J. Now these are the 10 people. We are giving them rank on two parameters, beauty second is intelligence. Right, these are the two parameters. On behalf of these, we are giving them ranks. Okay, so let's give them rank. Let's suppose person A is the most beautiful one. Then we have person D. Then we have person G. Then E. Then J. Then I, then F, then H, then B, and then C. Now next, intelligence. So over here, let's suppose the most intelligent person over here is D. Then we have his F. Then we have his I. Then G. Then we have C, E, J, H, B, A. So this is over here we have given them ranking. Now see, when we are giving these ranks, just notice one thing. I have given it in the form of either ascending or descending, which is same for both the characteristics. Like if I'm giving rank 1 to the most beautiful person, then I'm again giving rank 1 to the most intelligent person. This has to be uniform. If we are giving, or in case we are giving rank 1 to the least beautiful person, then we need to give rank 1 to the least intelligent person, right? So these are two different ranks, or these are ranks based on the different characteristics. So can we say these are pairs of ranks for each individual, right? So these are the ranks. So now what we will do is we obviously cannot, if we want to find any association between these two rankings, like obviously this can turn up in our mind, what is the association or correlation between these two characteristics. So what we will do is, we will use these ranks in order to find the correlation coefficient. And since we are using these ranks or these scores, we are naming it as coefficient of rank correlation, right? So now let's see how to find these. Let there be n pairs of values of two ranked variables or two rankings of a variable. So this we have already talked. Let there be n pairs of values of two ranked variables. Now we have n pairs, right? So these are pairs now. These are all pairs where we have taken these 1 and 10. These are all pairs of different ranks. So since we have n individuals over here or 10 individuals over here, so we are using these pairs, right? Since we have n individuals, so we have these n pairs. The ranks may already be given or may be obtained by ranking the given values as 1 to n in ascending or descending order. This also we have already talked. Now we are saying, if this is so, where we have n pairs of values of two rank variables, then Spearman's rank correlation coefficient is equal to 1 minus 6 into summation d square upon n cube minus n, where d refers to R1 minus R2, as in if we have these ranks, like suppose beauty represents R1 and intelligence represents R2. So the difference between these ranks will be D, right? And then we are just squaring these up. We are summing them up. We are multiplying it by 6 upon n cube minus n. N refers to the number of pairs or the number of observations. And we are subtracting this entire thing from 1. So this is the basic formula in order to find the Spearman's rank correlation coefficient. Now again, the value for this RS or Spearman's rank correlation coefficient will always lie between 1 and minus 1. Just like Carl-Pearson's correlation coefficient, right? So it's all same. I'll also show you why, from where did this formula turn up. About this we will discuss in the next video, but we will see that this is nothing but again the Carl-Pearson's coefficient of correlation. But the only difference is over here we're using the ranks instead of using the actual numerical measures, since this data is non-quantifiable, right? So now we'll talk about this, that Spearman's rank correlation coefficient lies between minus 1 and 1, right? If Spearman's rank correlation coefficient is minus 1, this means there's a perfect negative correlation, right? And if it is equal to 1, that is there's a perfect positive correlation, right? So now let's see. Now we will see that how is it actually true. So let's suppose we are given a data where we have given ranks. Let's consider first this part of data, this half. So R1 and R2, where ranks are such that R1 is 1, then R2 is also 1. If R1 is 2, then R2 is also 2. If R1 is 3, R2 is also 3. And if R1 is 4, then R2 is also 4. Now let's find Spearman's rank correlation coefficient for the same. Now we know Spearman's rank correlation coefficient is rho is equal to 1 minus 6 sigma d square upon n cube minus n, right? We can either write it this, or this is also equal to 1 minus 6 sigma d square upon n into n square minus 1. You can use either of the two, it's one and the same thing. I've just taken out this n outside, so if you multiply it, denominator will always remain the same. So let's first find d. What is d? We also know d is equal to r1 minus r2, right? Okay, so let's find d. D, for this r1 minus r2 is 0. This is again 0, 0, 3 minus 3, 4 minus 4 is again 0. So if we find d square, this will again be 0, 0, 0, 0. So now we have found d and d square. Next we need to do is summing up this our d square, right? We need to sum up our d square. So this will be all 0. Now if we see and put this in the formula, what we will find is, okay, so from here let's just write it down. One minus 6 summation d square means 6 into 0 upon n. N is 4 into 4 square minus 1. Right? Now this becomes 1 minus 6 into 0, 0. This becomes to 1. So the correlation coefficient over here is 1. Now if we have this R1 and R2, again let's find this D. So here we have this 1 minus 4 is minus 3, 2 minus 3 is minus 1, 3 minus 2 is 1, 4 minus 3 is 3. Now we again will find d square over here. So d square will be 9119. Summing it up, 9 plus 9, 18, 19, 20. So this becomes 20. So now if we put this, for this row will always be equal to 1 minus 6 into summation d square is 20 upon n is 4, 4 square minus 1. So this becomes 1 minus 6 into 20 upon 4 into 15. Right? So this becomes 1 minus 120 upon 4, 16 minus 1, 15. 15 upon 15 into 4 is 60. So this becomes, cancelling it out. So this becomes minus 1. Right? So now we have seen that this will always lie between minus 1 and 1. So whenever the coefficient, whenever they are exactly correlated like this 1, 2, 3, 4 and the R2s are also 1, 2, 3, 4. In such cases, what we will say, in such cases the correlation coefficient will always be equal to 1. And in case it's totally inverse, like if let's suppose we have first rank for individual A and for another characteristic we have the lowest rank, in such cases, and we have ranks like if R1 is 1 and R2 is 4, if R1 is 2, R2 is 3, such case our correlation coefficient is minus 1. Right? Okay. So next let's move on to the example that how to find a correlation coefficient for a given data. So that was a very simple example. Over here we will find it out how to compute it. So rankings of 10 trainees at the beginning and at the end of the certain course are given below. Find Spearman's rank correlation coefficient. 10 trainees means, let's just start writing out the information. N is equal to 10. Right? Okay. So we have rankings at the beginning. Ranking at the beginning is R1 and let rank at the end be R2. Right? Now what is the formula for Spearman's rank correlation? Spearman's rank correlation coefficient is equal to 1 minus 6 summation d square upon n into n square minus 1. Right? So now this is 1 minus 6 into summation d square. So for this we need to find d square. So let's first find is d. Right? So what is d? D is nothing but R1 minus R2. Okay, so 1 minus 6 is equal to minus 5, 6 minus 8 minus 2, 3 minus 3, 0, 9 minus 7, 2, 5 minus 2, 3, 2 minus 1, 1, 7 minus 5 is 2, 10 minus 9 is 1, 8 minus 4 is 4, 4 minus 10 is minus 6. So now here we have all the d's. What do we need to do after this? After this we need to find is d square. Right? So let's just square these up. 25 minus 2 into minus 2 is 4. 0, 4, 3 into 3 9, 1, 2 square is 4, 1 square is 1, 4 square is 16 and 6 square is 36. Right? Now after this we need a summation of this d square. So summation d square is equal to, we need to just add these up. Adding this up will give us 100. Right? Now we'll put it in the formula. So if we are putting this in the formula, so yeah, 1 minus 6 into summation d square means 100 upon n is 10 into 10 square minus 1. Right? So this is equal to 1 minus 6 into 100 upon 10 into 10 square is 100 into 99. This cancels out. This becomes into 2 and this becomes 33. So this becomes 1 minus 20 by 33, which is equal to 33 minus 20 upon 33, which is equal to 13 upon 33, and this is equal to 0.394. Right? So this is how we find the Spearman's rank correlation coefficient. Right? Okay. So now next we will talk about is the merits and demerits. So when we talk about merits and demerits, first of all, we all know it's quite easy to find Spearman's rank correlation in comparison to Carl-Pearson's coefficient of correlation, right? But the most important merit is it is the only method, right, that can be used to find correlation coefficient when we have qualitative data. Qualitative data. That is when the data cannot be quantified, right? Although this method can be used in case of quantitative data also, but when it comes to qualitative data, only Spearman's rank correlation coefficient comes to our help, right? So this is the only method that can be used where we are given the ranks. In case we are given ranks, we can only given ranks, we can use only this method, right? In case we are either given only ranks or we are only given qualitative data, right? Because Carl-Pearson's coefficient of correlation cannot be used when we have ranks, but Spearman's rank correlation coefficient can be used when we have numerical data also, right? Okay. Now let's talk about demerits. It's quite difficult when we have larger number of observations, right? So difficult to apply. When we have large number of observations, right? Second is cannot be used in case of bivariate frequency distribution. Bivariate frequency distribution, right? Why? Because in case of bivariate frequency distribution, we cannot use these. Okay? Yeah. So this was the basic concept of Carl-Pearson's coefficient of correlation, Spearman's rank correlation coefficient. In our next video, we'll talk about different cases that over here, as we saw, we were simply given the ranks. Now next video will talk about what happens when we are actually not given rank or when we have the common ranks. When the ranks are common between different observations. So we'll talk about this in our next video. I hope you like this video. Do subscribe this channel for more videos. Thank you.